Hello friends, in this video I'd like to solve the following problem from the Turkish Mathematical Olympiad final round 1998, problem number 4. We wish to find all positive integers x and y such that x cubed plus 3367 equals 2 to the power of y. So my hints for this problem, first of all factorize 3367 and then do a reduction modulo some number, it's a mystery for now, which will show that 3 is a factor of y. And then, if you know that 3 is a factor of y, then you can put x cubed on the right hand side and do a factorization of the right hand side. So give it a try and I will see you in a moment. Okay, so I hope that you have come up with a solution. My solution goes like that. First of all, 3367, it's 7 times 13 times 37. It's pretty easy to factorize this number. And now I will do reduction modulo 7. Why modulo 7? Because after reduction this number will disappear, because 7 is its prime factor. So reduction modulo 7 will do the trick. Okay. And now after reduction we have x cubed is congruent to 2 to the power of y modulo 7. And now let's look at the possible values of x cubed and of possible values of 2 to the power of y modulo 7. The possible values are as follows. Let's notice 0 cubed is congruent to 0, plus minus 1 cubed is congruent to plus minus 1, plus minus 2 cubed is congruent to plus minus 1 again, because it's 8 or minus 8. And finally, plus minus 3 cubed is congruent to minus or plus 1. Of course, we are talking modulo 7. And let's look at the right-hand side, 2 to the power of y. And let's notice, 2 to the power of 0 is congruent to 1. 2 to the power of 1 is congruent to 2. 2 to the power of 2 is congruent to 4. 2 to the power of 3 is congruent to minus 1. Then we have minus 2 and minus 4. Okay, and finally 2 to the power of 6 is 64, and 64 is back again congruent to 1. And now let's notice that 0 doesn't appear on the right hand side, so modulo 7. So that means that both sides must be congruent either to 1 or to minus 1. And let's notice that congruence to 1 or minus 1 appears only when the exponent is divisible by 3. That means that 3 must divide y. And it's very helpful because now we can do the following. We can take our equation once again, and we can write the right hand side as 2 to the power y cubed, y over 3, quantity cubed. And now we can take our left hand side, it was 7 times 13 times 37, and we can put x cubed on the right side and we can do the factorization. 2 to the power y over 3 minus x, 2 to the power 2y over 3 plus x 2 to the power y over 3 plus x squared. Great news, we have some kind of factorization. And now let's consider our options. First of all, let's notice that this number, both of these numbers are positive. Moreover, the number in the first parenthesis is less than the number in the second parenthesis. So we have only the following options. Either the first parenthesis is 1 and the second parenthesis is 3367. Copy that. Or the second option is that the first number is 7 and the second number is 481. The third possibility is that our first number is 13 and the second number is 259, and the last option is that the first number is 37 and the second number is 91, sorry. Okay. In other cases, we will have the number on top bigger than the number on the bottom. So it cannot happen. And so now we should just solve these equations. From the first equation, we get that 2 to the power y over 3 equals x plus y plus 1, sorry. And you can put this in the second equation, and you will get x plus 1 squared plus x times x plus 1 plus x squared equals 3367. And after solving this quadratic equation, you will get x equals 33. But after manual verification, that means that 2 to the power y over 3 equals 34, and this is not possible because 34 is not a power of 2. In the second option, we will get 2 to the power y over 3 equals x plus 7, and that means that x plus 7 squared plus x times x plus 7 plus x squared equals 481. And now it turns out, after doing some arithmetic and so on, x equals 9, and that means that 2 to the power y over 3 equals 16, and that means that y must be equal to 12, because 12 over 3 is 4, 2 to the power of 4 is in fact 16. Okay, so we have one pair of solutions. And now you can do the same for the third equation. 2 to the power y over 3 equals x plus 13. So x plus 13 squared plus x times x plus 13 plus x squared equals 259, which means that x equals 2, but that means that 2 to the power y over 3 equals 15. It's not possible because 15 is not a power of 2. And finally, the final equation, 2 to the power y over 3 equals x plus 37, and that means that x plus 37 squared plus x times x plus 37 plus x squared equals 91, and that has no solution, no real solution. And that closes our problem. So we know that our equation has only one pair of solutions, namely, write it maybe, here. Only solution, x equals 9, y equals 12. There are no other solutions. Okay, so how Thank you for watching. I hope that you have learned something new this time. I hope that you have managed to solve this problem, and see you next time. Goodbye.